Alright, this was a test on a basic circles unit where we learned about circles, arcs, angles, and segments. So let's break it. If you well, let's see. If these if this is a perpendicular bisector, which it obviously is, it's going to bisect the chord, the arc up here as well. So these pieces of the arc are also congruent, so keep that in mind. So what we have here is a semicircle. So if this is 130 degrees, then this is going to be 50 degrees because they have to add up to 180. But if this is 50 degrees, then this will also be 50 degrees, and together they make 100 degrees. Alright, so that's the measure of arc MN. Okay, FC, when you see two letters together with no symbols or anything, it means distance. The distance from F to C. In other words, it means the length of segment FC. So that's what we're supposed to find. Now the key is a theorem that we learned that if you have a chord that is the same distance from the center as another chord, when I say distance I mean perpendicular distance, then those chords are the same length. So you see these marks right here and here. That means that these chords, EC and AG, are the same distance away from the center. So AG and EC must be the same length. Also, because the line BD is perpendicular and it's a diameter, then it must be a bisector. Okay, that's the theorem that we learned. If you have a perpendicular diameter, it's also a bisector. So if this is 4, then this is 4. That means AG is 8, which means EC is also 8, which means that these pieces are also 4 and 4. Which means that FC, of course, is 4. Alright, number 3, trying to find the value of x. Alright, this type of problem depends on determining which formula we're going to use. And we learned about things like this, where we want to work with segments and the circle. So in a case like this, part times part equals part times part, like R times M equals D times K. But if it's coming outside of the circle like this, then we learn that part times whole is equal to part times whole. And when I say part times whole, the part is always the outer part. So of course that's the situation we're in here, where we have to set up the equation that part times whole is going to equal part times whole. So for this upper secant, part times whole is 4 times x plus 4. Okay, 4 is the outer part, x plus 4 is the whole. And that's going to equal part times whole, where the outer part is 5, and the whole is 5 plus 4, which is 9. So now it's just a matter of solving this. So we have 4x plus 16 is equal to 45. Subtract 16 from both sides, and we will have 4x equals 29. And then we need to divide both sides by 4. So that's going to give us x equals 7.25. So that's the answer for number 3. Well, the direction said round to the nearest tenth, so that's 1 decimal place. So technically, because this is a 5, we should round this up to 7.3. For number 4, we are dealing with the other formula inside the circle here. Part times part equals part times part. Okay, so that means, so looking at this blue chord, okay, that's 9 times 4. Okay, and let's see. Looking at the purple chord, alright, that's 6 times x. So we have 6x equals 36. So if we divide both sides by 6, we get x equals 6. Alright, number 5. Again, we are outside of the circle. So we have part times whole equals part times whole. Okay, now looking at the x, x is the part and the whole. So that means x times x, okay, which is going to be x squared. But up here, 12 is the part, and this is the whole, 12 plus 4. So it's going to be 12 times 16. Alright, part times whole. So that's going to make x squared equals 192. So if we take the square root of both sides, that gives us x equals 8 radical 3. Okay, that's the exact answer. But to the nearest tenth, that's 13.9. So that's it for number 5. Number 6 is almost the same thing. Alright, part times whole. Okay, so that's 20 times x plus 20 is equal to part times whole. Okay, 31 is the part and the whole. So that's going to be 31 times 31. So distributive property here gives us 20x plus 400 equals 961. Subtracting 400 from both sides gives us 20x equals 561. Now dividing by 20 on both sides gives us x equals 28.05. To the nearest tenth, that would be 28.1. So that's it for number 6. Alright, for number 7, when you have these two tangents that converge at a single point, then these are going to be congruent. So all we need to do is set 7x minus 2 equal to 3x plus 8. Let's get these x's together by subtracting 3x from both sides. So that's going to leave 4x minus 2 is equal to 8. Then if we add 2 to both sides, that's going to give us 4x is equal to 10. Of course, then we will have to divide both sides by 4. And that's going to give us x equals 2.5. So that is it for number 7. Same thing for number 8. These tangent segments are going to be congruent. So that means 4x minus 8 is going to equal 2x plus 13. So subtracting 2x from both sides leaves us 2x minus 8 is equal to 13. Adding 8 to both sides gives us 2x is equal to 21. Dividing both sides by 2 gives us x equals 10.5. So that's it for number 8. Okay, for number 9, we are given this crucial information that point G, right here, is the incenter of the triangle. And then we're supposed to find segment BG, which is right here. Well, the main special property that we learned about Incenter is that it is equidistant to the sides. Okay, it's equidistant to the sides. That means these blue segments are all going to be congruent because these are the distances to the sides. So this, and this, they're all equal. Well, wait a minute. That means I already know what BG is. I don't even have to do the Pythagorean theorem or anything. BG is 16. Alright, because GF is 16, so all of these blue segments are 16. So that's it. Alright, is there some special place I'm supposed to write it? I guess this is it. BG equals 16. Alright, for number 10 through 14 here, we're supposed to use the drawing to the right to name the point of tangency, or a point of tangency. That's K. Okay, radius. Let's see, from the center to the edge. PN is an obvious one, segment P, but I could also say PK, PQ. I could even do PJ or PV. So let's see, what did I say there? So I could have said, whoa, why did I put an R? Silly me. Okay, so segment PK or PN or PQ. Alright, those are the obvious ones, but there are even more than that. So secant. A secant is a line passing through the interior of a circle. Okay, so an obvious one would be VJ. Alright, line VJ. But technically you could have said line PN or line NM or line KM. There's like several of them that you could have named. But this is the only one that's shown as a line. So line VJ or JV. Alright, notice the line symbol over the top. See how it's different than the segment symbols? A secant is a line, so you better use the line symbol. If I said JV, but I put a segment symbol over the top of it, like the radii, then that would mean that it would begin at J and end at V. That would not be a secant, that would be a chord. So if you put JV with a segment symbol, it's wrong, completely wrong. Okay, tangent. Of course, a tangent is a line or segment or something that touches the circle at a single point. Okay, so the tangent is line KL. Alright, it's not wrong if you said segment KL, for example, because a segment can be a tangent as well. A major arc is an arc that is bigger than half the circle, bigger than 180 degrees. You must use a three-letter designation to name a major arc. Otherwise, if you just pick two letters, it's assumed to be the short way. So there are many possible answers that you could put. But one example would be, alright, say if I look, this would be an example of a major arc. Okay, so I could say arc JKV, or could have been the same arc could be named JMV or JNV. By the way, don't use more than three letters. Don't say, look at arc JKMNQV. Don't say that. Just three letters, please. So I'm not even going to write down an answer here because there are so many possible correct answers. Alright, number 15. Use the drawing to the right to give the measure of the arc or angle. Assume that X is the center. Well, duh. Okay, anyway, calm down, Burton. Angle RSW. Little bootleg angle symbol. It's bothering me. Angle RSW. Let's see. RSW goes from, if I look from R to S to W, then this is the angle that we're talking about. Now, the arc that goes with that is this right here. Now, this is an inscribed angle. It's on the border of the circle. So the relationship is the angle is half the arc. So if the arc is 64, the angle should be 32 degrees. Okay, arc TU. Measure of arc TU. Okay, this is arc TU. And we got to figure out what that is. However, notice that this is a diameter. So that means this is a semicircle. Alright, so if you keep that in mind, notice that, let's see, this part of the semicircle is all given, 37 and 96. Alright, so that means the remaining TU part, we should be able to subtract from 180 degrees to find it, because the semicircle altogether is 180 degrees. So if I start with 180 degrees for the whole semicircle, and then subtract 37 degrees and subtract 96 degrees, that should leave the measure of arc TU. So let's do that. So if I go 180 minus 37, right, is that what it was? Minus 96. That's 47 degrees. Okay, awesome. What about the measure of angle WXV? Oh, this is a toughie. This one's gonna be rough, y'all. It's gonna be tough, y'all. Let's see, I like to do the angles in pink. WXV goes from W to X to V. Well, this is a central angle. Notice the vertex is at the center. The central angle should be the same as the arc that is intercepted. So since arc WV is 37 degrees, then angle WXV is also 37 degrees. Brilliant. Alright, that's it for that part. Let's see, find the measure of angle BFC. Okay, angle BFC is this angle right here. I'm going to call it theta because it's shorter than writing BFC. So, there's a formula for this type of situation. We have learned that when you have an angle that's inside of the circle like this, alright, I mean it would be the same on both sides because these are called vertical angles, but just pick side. The relationship between the angle and the two intercepted arcs is this. The angle is equal to one arc plus the other arc divided by 2. You might see this as the average. If you add up two numbers and divide by 2, that's the mean, the average. So that's what you do. Angle equals arc plus arc divided by 2. So that's what we have here. So that means this is going to be a straightforward application of that formula. The angle is going to equal to arc plus arc divided by 2. Ah, 39 degrees. I have a place to write that? Yeah, looks like I do. 39 degrees. Yeah. Alright, that's it for number 18. Alright, number 19 is very similar. Please understand that the angle JLN is this angle right here, which I will once again call theta. Please understand that this arc is not this angle. Alright, the arc, this 42 is for the arc. Otherwise, they are just giving us the answer, and they're not. So we have two intercepted arcs, and they are these. And we have this angle that is intercepting them both. That is, let's see, let me scroll down. That's this situation, alright? It's a very similar formula, but this time angle equals arc minus arc divided by 2, instead of arc plus arc divided by 2. And it's important to do the big arc minus the small arc, so we don't get a negative number. So this will just be a straightforward application of that formula. So again, the angle is equal to the big arc minus the small arc divided by 2. That's 34 degrees. Alright, that's it for number 19. Alright, number 20 should prove to be very easy for you, my friends. They are telling us that segment LM and segment NP are congruent. So that means that these chords are congruent. We have learned that if the chords are congruent in the same circle, then the arcs that are go with them are also congruent. So, well, what's arc PN? Well, this is a central angle, so the angle measure and the arc measure are the same. So that means that this is 98 degrees. And like I said, if the chords are congruent, then the arcs are congruent. So that means that this is also 98 degrees. And that is what we were supposed to find, the measure of arc LM. Alright, it's 98 degrees. So there you go, it's B. Okay, quadrilateral WXYZ is inscribed in this circle. Which statement must be true? Oh, they drew a picture for us and everything. Well, without even looking at the question yet, the one thing that we've learned about a quadrilateral inscribed in a circle is that opposite angles should be supplementary. Okay? In other words, you know, W and Y should be supplementary. They should add up to 180 degrees. Z and X are supplementary. So that's what we are looking for. So W and Y, yeah, well, that says complementary, so it's not A. W and Y are supplementary. That's what it is. Just checking through the rest of them. Z and Y, no, those are not opposite angles. So yeah, so it's not either one of these. So it's definitely B, because we've learned that opposite angles are supplementary. That means they add up to 180, by the way. Number 22, which of the following cannot be lengths of a triangle? Well, the key for this, to make a triangle, the two smaller sides have to add up to be more than the biggest side. So, for example, here the biggest side is 5. So that leaves 3 plus 4. Well, 3 plus 4 is 7. And 7 is greater than 5, so that one's okay. Okay, the two smaller sides have to be more than, not equal to, but more than the third side. How about this one? Well, the biggest side is 13. So that leaves 5 plus 12. And, you know, that's 17, which is definitely greater than 13, so that one's okay. Okay, this one, the biggest side is 8. Well, that leaves 4 plus 6 which is 10. That's bigger than 8. So that one's okay. So it must be the other one that's messed up. So let's check it out. The biggest one is 9. Okay, that leaves 3 plus 6. Well, 3 plus 6 is equal to 9, but it's not greater than 9. Alright, that's not good enough. So if I had one side that's 9, and then I had another side that was 3, and another side that was 6, okay, they would touch, but only if the two sides laid completely flat, and that would not make a triangle. There's nothing left over. Okay, if one side is 6, okay, and the other side is, say 4, okay, now this side is 9, well, this makes 10, so that leaves just enough extra to make a little tent out of it. But if there's nothing left over, these are just going to fall flat, and that does not make a triangle. So anyway, it can't be equal to, it has to be greater than. So that's why D cannot make a triangle. Alright, number 23 is clearly a review problem. A 12-foot ladder is leaning against a building at a 75-degree angle with the ground. And they even gave you the picture. Okay, so not even really a word problem. Easy peasy lemon squeezy is what I'm trying to say. Which can be used to find how high the ladder reaches up the side of the building. Okay, in other words, which can be used to find x here. So let's see. Now, if we were just solving this, all right, forget about the choices for a second. Looking at the two things that were given, well, the one thing that we're given is the hypotenuse, and then there's the thing that we are looking for, which is the opposite leg. Okay, from the perspective of this angle, it's the opposite leg. So if we were going to use this information, opposite and hypotenuse, we would definitely be thinking about the sine function, okay, because we have learned that sine of an angle is the opposite leg over the hypotenuse. Okay, so that's x over 12. Okay, so if I look back and this is one of the choices, then that'll be the answer. If it's not one of the choices, then we'll have to switch to the other angle, which won't be too hard to do. So let's look for this. Sine 75 equals x over 12. Oh, look, there it is right there. Sine 75 equals x over 12. Okay, so the answer is definitely D. And that is the end of this video. It's the end of this test, ladies and gentlemen. So I hope you found this video to be helpful, and I will see you on the next video.